In this last overview video on the material from this chapter, I just want to briefly talk about the idea of connectedness. Technically, this is a little bit stronger than connectedness. This is a version of path connectedness, but think about it as connectedness. So if we have a region in the plane, let me draw one that we kind of haven't really seen before. Suppose it looks like a peanut, maybe up here looks like a heart, I don't know. And then maybe some of it is included and some of it's not. Okay, so here is our region. And some of the boundary is there, some of it's not. So let's just notice here, this is neither open nor closed. It fails to be open because of boundary points here. And the lack of the boundary points here fails the closed condition. That is, you're closed if and only if you sort of have all your boundary points, and we're missing some of them. Okay, so that's not the point of this video. Just wanted to draw an example of a set which was neither open nor closed. And those things exist, and most sets aren't open or closed. So being open and or closed is a special thing. Now, this set, however, is what we call connected. Namely, any two points can be joined with a path, or your book says a bunch of lines, but we can think about it as a path. So if I pick some random points, let's say Z0 and maybe Z1's all the way over here, I could pick a path of straight lines where I go like that, and then I go like that. And if we picked any other 2 points, we could create a similar path. Either we could do the straight line path. The straight line path doesn't quite work from Z0 to Z1. But maybe you have a Z2 over here, in which case we could just try to do the straight line path. Oops, I missed it. And if we can't do the straight line path, well, in here we can go around to do the straight, and then go around to some point where we could then just march over to Z1. So this is an example of a connected set or a connected region. Technically path connected, but whatever. Now, what's an example of something which is not connected? Well, most things are not connected. So we'll draw some silly ones, a silly one and a less silly one. An obvious example is something like, maybe you have a disk over here, and then maybe you have a disk over here, and then maybe you have, I don't know, something like this over here, some sort of annulus over here. This is not connected. Instead, it has 3 connected components. What's a connected component? It's what you think it is. Oops. I don't know why it inserts the E. Components. It's a connected piece. So individually, each one of these 3 is connected, but when we view them as a whole, they're not. We have 3 distinct pieces. Okay. Now, a weirder set is to, let me use just a dot. Here, our sets could be just points, right? And then maybe we have, and this is just the bounding shape. I'm not going to fill in the middle. So this guy is also not connected. How many connected components are there? And this is why it's important for us to not look at connecting with linear paths, because some of our contours, we want to be connected like this. This is a nice connected shape. But it's curvy, so you can't connect points with paths. So how many connected pieces are there? 1, 2, 3, 4, 5, 6. Okay, so that's another idea that was introduced in this section. So we have open, closed, and connected regions.